they're in the back there. Okay, so basically, this whole unit is about learning 5 different ways to solve the same type of problem. Okay? So last week, we did it all algebraically, where we had to do elimination, substitution, and all that stuff. And it took you 15 minutes to do one problem, right? Okay, so this week, I'm going to show you how to do it with the matrices, and show you how to do it in about, let's see, the first method, it'll take it down from 15 minutes to about 10 minutes. And then the second method will take it down to about 3 minutes. And then you get mad at me and say, well, why didn't you just show us this to begin with? But
I have a real, so these are like a different way to answer the same thing.
yes.
So like you can still answer it
Yes.
the way before.
And we'll get to that later for the final part where you get to pick what method. But all the 5 methods that we're going through in this whole unit, we're going to use the exact same problems. So I can show you that it's just does it the same way. What? Okay. All right. So this basically is going to be like our packet of notes and stuff for the whole week, or the rest of the week. Okay. We're going to do a little bit of notes every day, then do a little bit of practice every day, that kind of stuff. This is the part of the unit that you are going to want a graphing calculator. You need to bring, you're not going to want to come without your graphing calculator every single day. I don't have one, I'm not loaning them, and you're going to have it. You just, because like Thursday and Friday, it's all on the calculator. Okay? I'll show you tomorrow how to do it on the calculator too, but sometimes it's easier to do it in your head.
Are there any more problems in this? I don't have it.
In the back, in front of 10. In front of 10, since yesterday was the 10th. Alrighty, are we ready? A lot of definitions and kind of easier stuff today. So, until we get to row operations. So, whole basic of this unit is called a matrix, okay? And a matrix definition is a rectangular array, meaning array is like a set, okay? Of variables and constants, and it's all in rows and columns that are enclosed by brackets. Okay? And plural, it's called matrices. Okay? Entry or element is basically what we call for each position in a matrix. Okay? Each spot, each number. Okay? And remember how or maybe when we were talking about the rubric yesterday, and I said the first 2 questions were a 2x2 because it had 2 variables and 2 equations. That's what a matrix is named by, okay? It's named by the number of rows times the number of columns. So it always is rows times column, okay? So this would be row 1, this would be row 2. Because rows are side by side. Okay, this would be column 1, that would be column 2. So A is a 2x2. Make sense? Okay. All right, for B, we have row 1, row 2, row 3. So it's a 3 by column 1, column 2, column 3. So it's a 3 by 3. That was your problem number 3 and 4 on the skill quiz. They were 3 by 3s. Okay? right, last one, I have row 1 and I have row 2. Then I have column 1, column 2, and column 3. So that makes it a what? 2 by 3. Perfect. Easy peasy? All right. What do you think a square matrix is then?
Same?
Yeah, has the same number of rows and columns because it makes them a square. So like A and B are square matrix. Okay, because they have the same rows and columns. And that some methods require you to have the same number, some of you don't, kind of thing. And an augmented matrix is a matrix used to represent a system of equations. So, when we look at our system here, looks just like some of the problems you had on the quiz, right? Okay. To write it as a matrix, you take the coefficient of each of them. So basically, column 1 is my x's. Column 2 are my y's. Column 3 are my z's. And then you have a line that represents your equal. And then you have the last one. I always call it the total column. I don't know why. It's like what it equals. And you just take your coefficients. So I have 3 x's, I have 5 y's, I have negative 1 z, and I have 7 totals. Does that make sense? So this next one, if I didn't even look at this one, I could say, hey, I have 2 x's. Yep. I don't have any y's. No y's. I have 3 z's. Yep. And a total on the other side of the equal side is negative 2. Okay, does that make sense? Okay, so when you're writing an augmented matrix, you want all your variables on the left side of the equal sign, and you want all your constants or totals, whatever you want to call it, on the right side. And just like we showed here, I didn't have any y's. You have to have 0 in, think of it as a placeholder. Okay? All right, there's 2 more. We have what's called the coefficient matrix. And it's the matrix made up of the coefficients. What's coefficients mean? Yep. It's the number before the variable. Okay. And it's made up the coefficients of the equations of the matrix. So basically, in our example, it's everything on the left side. Okay, that's called the coefficient. We'll need to know what that one is when we do determinants the following week. All right, last one is the main, well, to start with, is the main diagonal, okay? Main diagonal is an augmented matrix, and the diagonal elements of the square or coefficient matrix. Okay, so what does that mean? I have just the coefficient part here, okay? this is my main diagonal. Good so far? Yes? All right, we're going to do these two last definitions and just learn to do some row operations first. All right, so flip the page. Okay, thing about row operations or row is that we can manipulate and move stuff around to be able to use it for how we're going to solve it, which I'm going to show you like tomorrow. Okay, so there are three. Okay, first off, what do I mean by operations? No, what's it mean just in general? In math, what's operations mean to
The way
you?
to set it up
What's addition, subtraction, multiply. You're making it much more complicated than it is. Yeah, we're just talking about addition, subtraction, that kind of thing, okay? With row operations, it's not quite the same. There are three different things that you can do, okay? The first one is you can just interchange the two rows. You could say, I'm moving this row and this row. You just flip them, okay? So, for instance, if I want row 2 to equal row 1, all right? This is row 1, this is row 2, and this is row 3, right? Okay, when interchange means just a flip, that means, so now my row 1 becomes 2, -6, and 0. My row 2 becomes 3, 2, and 2. Okay? I didn't have any operation with row 3, so it just stays the same. Okay, does that make sense? Okay, the second thing I can do is I can replace a row by a non-zero multiple. So that means I can multiply the row. All right? So I'm going to take row 2 and I'm going to multiply it by -3. So here's row 1, there's row 2. Row 1 I didn't do anything with, so it stays exactly the same. But row 2, I'm going to multiply every element by -3. So -3, 1 becomes -3. -3 times -3 becomes +9. And then -3 times -5 becomes 15. Okay, good. All right, those are the two easy peasy ones, right? All right, number 3, you replace a row by the sum of that row and the constant multiple, okay? So it's like you do two things. So for instance, I'm going to say that row 2 I'm going to multiply the first row by 9, and then I'm going to add it to row 2. So row 1 doesn't change anything at all. All right? So my very first position is I take row 1, which was a 1, and I multiply it by 9, which gives me 9. and then I add it to row 2. So I have 9 minus 9, which is going to give me 0. My second position, okay, I have a second position here. I'm going to multiply, so 9 times row 1. Row 1 is a 5. I multiply it by 9. That gives me 45. Then I add it to row 2, which is 6, which is going to give me 51. Okay, you with me?
You don't, why don't you write it and then?
You just write the answer. So I have 51. You just, my thing bled around a
There's
little.
no underneath it.
Huh?
Oh, it's just like a color of ox.
Yeah.
Yeah. Sorry. Okay, last position. I have 9 times negative 9, because that was row 1. That gives me negative 18. And I add it to row 2, which gives me negative 2.
Wait, 9 times 9 is 81.
Oh, I'm sorry. My dyslexia kicked in there again. All right, so that gives me negative 83. Okay. All right, those are the three. Let's do another example here on the row operation, because those tend to get, I don't want to say confusing, but it's easy to. So here's what I do, okay? I build my matrix, okay? And then I say, okay, I'm changing row 1. Okay, so this is row 1. That means that row 2 and row 3 are going to stay exactly the same. All right? So that means I just copy row 2 and row 3. And then I got 1, 2, 3, 4 positions that I got to fill for my operations. Okay? All right, so position 1. I have negative 1 times row 2. Row 2 is 8. Or I'm sorry, row 2 is 2. Which gives me negative 8. And I'm adding it to row 1, which is 9.
I have a question.
Yes.
You said negative 1 coming up.
Negative 4.
Oh, you said negative 1. That's why I was doing
Oh, sorry. Negative 4 times the 2 from row 2
plus 9.
plus 9, which gave me a positive 1. Okay? All right. Position 2. I have negative 4 times row 2, which is negative 5, plus row 1, which is negative 2. So 4 times 5 gives me 20 minus 2. So that position is going to be 18. Good? Okay. Yeah. That's just the rule. Yeah, it just said, hey, do this. I'll show you how we'll pick and we'll create the rules tomorrow. Okay? All right, last one. I got negative 4 times row. Oh, no, I'm sorry, not the last one, the second to last one. Times negative 7. And then I'm going to add it. Huh? I'm sorry.
Guys, you know what she means.
Yeah,
I can.
because you were listening and you weren't looking. I'm sorry. Okay, so -4 times 7 plus the 1 is going to give me -28 plus 1, which gives me -27. All right, now we'll do the last one. And I have -4 times what? -2. And then what? Plus -2. So I'm going to get 8 minus 2, which gives me 6. Okay? How do you feel about those?